Hello teaching team, this is the presentation of Group 52 for final project of COMP90054 Artificial Intelligence. We try to use multi-college research, reinforcement learning, and A-star algorithms to build up a competitive agent. My name is Yuhao Wang, and I will be introducing the designs and logic behind MCDS algorithm, although it failed at the end. Firstly, as you can see, this is the process of MCDS algorithm beating random agent. Obviously, it outperforms than the random agent. The very first step is selection, that it selects and visits a node from root node continuously until a leaf node is reached. During the process, extend the current node by taking value moves from the current state. Then evaluate the current node by rollout policy. The reward will be added up from the bottom of the tree to the root node, which is called a backpropagation. And while we didn't choose MCDS to be in the final tournament, for board game, MCDS needs lots of time to explore the search space. In this assignment, running time per move is 1 second. MCDS cannot explore search space effectively. Compared with A-star, the reward of MCDS is relatively sparse. A-star is guided by a heuristic function. For MCDS, it may need million times of random rollout to get a good evaluation of action. For future possible directions of improvement, one is that introduce knowledge of each game into MCDS, and second, replace the random rollout policy with customized policy, such as the policy in Q-learning. Thank you.
Hi, my name is Yuwei Gu. I will introduce heuristic search and the heuristic function A-star. Before choosing the algorithm, we refer to the reference case given by the teacher, the blend search algorithm BFS. But there is a disadvantage. BFS will search sequentially according to the search order. If the state space is relatively large, its efficiency will be very low. The heuristic search algorithm uses the current problem to search, which can reduce the search times and improve the search efficiency. So we think heuristic search will be better than blend search. A-star has the following advantages. It's fast. There will be fewer nodes need to be expanded. And it is completeness. The optimal solution can definitely be found, and the solution found costs the least. Because the space and time complexity of this game is limited, we have to find an optimal solution, so we choose A-star as a heuristic function. For the heuristic function, we found the minimum steps required to complete a sequence by traversing all the possible sequences of the game board for a given state. This is the result of playing A-star and BFS 20 times, and we can see that A-star beats BFS 85% of the time. This proves that our conjecture is correct. Then we optimize for primary A-star. For the current board, we only perform A-star when the minimum consumption value is less than or equal to 2. Otherwise, when there are more than 2 steps, all actions are traversed to minimize the corresponding number of the steps. It is found that the optimized A-star has indeed improved a lot and can surpass Staff Team Basic. Later, when discussing with teammates, I found that the strategy of preventing the middle position of the map in the first 5 steps is very effective for RF search. Therefore, we decided to add this strategy to A-star and compare it with the previous version, and found that this preemption strategy that is good for RF search but not good for A-star. So finally decided to use the 2.0 version of A-star.
Hi, my name is Yichen Liu. In my part, I will focus on the reinforcement learning. We choose Q-learning because it can achieve the optimal solution. Space complexity is a challenge. We use approximate Q function to solve this problem. We consider a linear combination of features and their weights. Therefore, instead of updating Q value, we only need to update the weights and the space complexity become acceptable. We have 7 features in total. We used E-greedy to train our weights. The advantage of reinforcement learning is as an offline algorithm, it can be trained locally first, and its thinking time will be very short. Disadvantage is that the Q value we have is not accurate because we use the approximate Q function instead of computing the real Q value, so we cannot get the optimal solution. Taking inspiration from David Peters' English player, we use hardcode to let our agent put the 5 rings in fixed position if without being blocked. If occupied, try to place rings as close to the center as possible. Reinforcement learning outperforms both multi-college research and A-star, but by submitting to the tournament, we found that A-star ranked higher, so we decided to choose A-star for the final tournament.
Let's tell a story of our techniques. They have their different advantages and disadvantages, and A-star had the best performance in the tournament, therefore participated in the final tournament. That's all for our presentation. Thanks for watching.